Okay, class, this is the second lecture of C programming language, and I am your computer teacher Madan Pandey, and I would like to welcome you all on the second lecture of C programming language. Today we are going to learn about a few control flows of C programming language. There are three types of control flow in C programming language. They are sequential or linear flow, decision making, or and looping. So first of all, we are going to discuss about sequential or linear order of control. So sequential or linear flow is the way in which the compiler is going to process each and every line one by one or one after another. And if this kind of processing is done, and this is known as sequential or linear flow. In sequential or linear flow, it never checks any conditions or decisions. In short, it does not make any kind of decisions. So the examples would be the programs to calculate areas, volumes of any surface. Let us try this program and discuss. Okay, there are few new things in this program. So first of all, I'll begin with the first line. This first line is known as the comment line. Since we know that there are two forward slash at the beginning of a string, and these two forward slash are known as single line comment in C programming language, which means that our compiler is not going to process this line, the very first line. It simply ignores this first line, as comments are important portions for a programmer to remember it for a later purpose. So the compiler is not going to process this line. So this is known as preprocessor directive, and we are simply including the header file stdio.h, that is standard input output.header file, so which basically contains the information of the library functions such as printf, scanf. Okay, so our program is going to be processed from the very first line of the main program, which is this. So we are going to elaborate some new ideas. So there are few new words like area and radius. So area and radius are the variables in this program. So variables are simply the name of a memory location where it is going to hold certain values, such as in this case radius is holding the value 3.2. So in short, a variable is known as the name of the memory location which can hold certain data. So which kind of data it is going to hold? It depends on the data type which is declared in front of the variable. So it is going to hold the variables radius and area are going to hold floating types data as it declared by our programming convention. In second line, we have added a new keyword const, which states that the variable pi is now a constant. So constant are simply a kind of a variable, but the value of a constant could not be changed throughout the program. So the difference between constant and the normal variable is that the variable's value could be changed if needed in any part of the programming, whereas the constant is going to remain same throughout the program. So what we are going to do in this program is we are simply calculating an area of a circle. So in order to calculate the area of a circle, we need a radius and a value of a pi. So since pi's value is pretty much same in every case, we have declared it as a constant value of 3.14. So in third line, we are calculating the value of value of an area by simply multiplying the value of pi with two times radius, that is radius multiplied with radius. So in fourth line, we are simply displaying the area of a circle, and this is something new which is encountered in the program. %f is known as type specifier. So type specifier in C programming language are used according to the data types. Since we have used the float data type, we'll be using %f. If we would have used int data type, we would have used %d. If character, then %c, and similar way. So why %f is necessary? If we need to print the value of certain variables, such as the value of one radius, which is 3.24 now, or the calculated value of an area, which would be something by multiplying the radius twice and then pi, multiplying it with pi. So if we need to print that value which is stored in the memory, and we could access those value of a memory address by simply typing the type specifier %f. These are special kind of symbols which are not going to be printed as it is as in normal case of printf. Instead of that, this first %f is going to print the value of an first variable encountered just after the closing of inverted comma, double inverted commas. So in this case, the first %f is going to print the value of an radius. So, and in a similar way, the second %f is going to print the second value, which is separated by this comma operator, which is area. So in short, this program is going to print the area of a circle having 3.2 radius is the calculated value of an area, that is that unit square. That is, run this program and then see the final output. Okay, the area of a circle, that is 3.2, having 3.2, and there are 5 more additional zeros appended. Radius is 32.153603 unit squares, which is the value of an area which is stored in a memory address. So let us modify this program a little bit. Instead of initializing this value to a certain constant, let me prompt for an input. So simply I will state that please enter the value of an of a radius, and after that I'll write a line scanf. Remember that C is an case sensitive language, which means that the capital alphabets and the small letters are distinct. So we should type is this spell exactly as we declared. So there is all in small case RADIUS, and in similar way like this. Okay, what these two lines, new lines, would do is that printf please enter the value of a radius. This is simply going to prompt the message which is displayed in double inverted commas, and the scanf function waits for us to input any floating value from the keyboard and carries that value to the variable radius. This is the syntax, this is the grammar we are talking about to write the scanf function. Scanf function has been already defined into the library stdio.h. So simply scanf is written as double inverted comma, starting of double inverted comma, the type specifier that we are going to use according to the data type. So if there is a float, we are going to use %d. If it would had been an int, would have written here %d. So, but for now, we will write it as %f, and the value of that variable is going to be kept inside the variable radius. So the the remaining part is going to be the same. Okay, let us run this program and see the output. Okay, please enter the value of an radius, and it is waiting for us to enter any value. Suppose I have entered the value 4.56. This is going to be our new radius. So what is here? The area of a circle having 4.56 radius is 65.291908 units square. So this program has become little more dynamic than the previous one. The previous one has the static value 3.2 attached to the value of an radius, whereas this program has it will prompt us every time we run this program, and it will output a different value. Suppose we run it the next time, and now I am entering the value of n radius to be 2.34, and see the value on the area of an circle has been changed since the radius is changed. Okay, so instead of writing in this similar way, we could use the function power. Okay, let me show you how it is done. I could use the power function POW and radius comma 2, since pi r square is the formula, the radius is going to be multiplied twice, that is radius times radius is 2 the power 2, and if this function POW function is defined inside the header file math.h, so we need to include that header file in our program. Include math.h. So let us save this, execute, compile and run. Okay, let me show you 2.3. Okay, it's still working. So that's all for today. So in sequential flow of a program, because the flow, that is, if the first line is processed in a similar way, then second line, third line, fourth, fifth, sixth, and seventh. This is the exact way the program is going to run. By any chance, suppose that by processing the first line, it cannot process the 10th line at once. So in order to reach the 10th line, it must process the line number 9, and in order to reach line number 9, it must process line number 8. In order to reach line number 8, similarly it needs to process line number 7. So this is the flow, and this flow is known as sequential or linear flow of programming. So that's all for today. We'll meet on the next lecture of C programming, and till then, thank you. Bye bye.